In the last video, we showed you the minimum complement of modules that you would need to be able to reproduce the vast majority of sounds. In this video, we will show you how to hook them up so as to be able to do that. The architecture that we will use is the same as many standard analog synths. Now, the main advantage of buying a modular is that you can hook them up in any way you feel like. Otherwise, you could just buy a standard synth in a configuration that's designed to produce the maximum number of sounds. The first thing we want to do is patch our gate. This is the signal from the MIDI module that is activated every time we press or release a key. We want to patch that into a multiple, and then we want to go from the multiple to our envelope generators. So there's a gate input on both of our envelope generators, and we want to patch the gate from our two envelope generators into our multiple and then out to the gate of the MIDI module. The next thing we want to do is patch the pitch CV from our MIDI interface. That gives us the note that is currently selected on the keyboard, the pitch of the note, into another multiple. You see how important the multiples are. We need a multiple anytime we have to go to more than one connection. The multiple is just what it means. It allows us to make multiple connections. Now, what we want to do with our pitch, as a rule, is send it to our oscillators so that the correct notes will be sounded. Now, there's a 1 volt per octave input on our oscillators, and we can go from our multiple to that. Now, we're going to go with both oscillators, but if you wanted to use one oscillator as a drone, that is, it would keep a continual pitch. Certain instruments require a drone. Then you would not make this connection. You simply would not put a wire to the 1 volt per octave input, and you would set a fixed frequency on that oscillator to get your drone. So keyboard tracking, which is normally a switch on most analog synths, is just a question of putting in a cable or not putting in a cable on your modular. Now, we want the outputs of our two oscillators to go to the mixer, okay? And the outputs here would be selected by determining which particular waveform we want. On your regular analog synthesizer, you'll flick a switch, maybe to select sine, triangle, sawtooth, square or pulse or whatever. On this one, you just determine which socket you want to plug your cable into. So once again, changing your waveform is usually a question of just moving your cable to a different socket on your oscillator module. And as I indicated, you will want to make sure that your oscillators support sawtooth and square waves, because the sawtooth has all of the harmonics and the square has the odd harmonics only, and these two wave shapes mimic the production of sounds in the majority of acoustic instruments. They either have vibrating strings or they have open or closed air columns, which produce similar harmonic spectrums to these two particular wave shapes. So if you only have two choices of waves on your oscillator, you want to go with the sawtooth and the square. Of course, most of them have sine triangles, and some of them have ramps and pulses as well. And there's the more different waveforms you have, the better for you. But if you're really being cheap and you're buying a very cheap oscillator, at least make sure it can switch between sawtooth and square. The last thing that we're going to put into our mixer is the source of noise. Now, as I said in the first video, the source of noise is very important because you need to add noise to be able to produce natural sounds, winds, oceans, thunder and lightning, as well as mechanical noises, scraping doors and all that sort of stuff. And it even helps to mix a little noise occasionally through the filter, of course, with your other oscillator waveforms to get the results you want for certain, if you're trying to mimic certain acoustic instruments. The output of your source mixing goes to your low pass filter. So we pick a signal input for our filter and we put it through our filter. Take the low pass output of our filter, and some synthesizers a switch selects low pass, high pass, band pass or notch. But as we were saying to you in the previous video, the low pass is the one that will mimic all your real instruments, your real acoustic instruments. So many simple synthesizers only have a low pass filter. They don't give you the option of other filters. So that's our audio path setup. We have the oscillators feeding into the mixer with the noise into the mixer as well, and the output of the mixer feeding through our filter, our low pass filter, into our amplifier and out to our sound system. And additionally, we've set up the pitch to control the pitch of the oscillators, and we've set up the gate to activate the envelope switch, will open and close the filter and the amplifier when we push the keys. Otherwise they will go on sounding a continuous pitch and there'll be no way to stop it. So what we have to do now is we have to quickly route the output of our envelopes. The first envelope to the filter, the second envelope to the amplifier. This allows our envelopes, our key action, that is, up and down, turning on and off of the keys, touching the keys, to control our filters. And actually I'll use a slightly longer cable there. The cables come in different lengths. The colors are associated with the different lengths so that you can reach the associated contacts on the thing. Now, the amount of effect that the individual envelope generators have on their respective things is controlled by a level. In this case, the level is up here. We can raise and lower the level to see how much the envelope affects the filter. And down here we have a control as well. We've wired it to a control here so that we can affect how much the envelope there affects the amplifier. And those would be knobs that would be already in place on the front panel of your dedicated synthesizer. Now there's one other connection here in our standard connections that is made in the majority of ready-made synths, and that is, if we have the filter set and it does not track the keyboard, then the tonal characters of the notes is going to change as you go from the low notes on the keyboard to the high notes on the keyboard. Now that may be a desired effect, in which case you just turn off keyboard tracking on your filter section in the ready-made synth, and in this particular one you simply remove the cable. So in other words, the switches on a normal synth are replaced by the action or removal or insertion of cables on your modular synth. So we're going to plug the filter input that controls the cutoff of the filter into our pitch multiple here, so that you can basically adjust the filter for the particular place on the keyboard you are. Whether you're in a high octave register or a low octave register, you'll be able to have the filter move along with the keyboard and produce a more consistent tone. Your tone character will remain the same across the entire keyboard. Now, we've used all of the modules that we showed you in the first video, with the exception of the LFO. We haven't done anything with the LFO. We have to decide what we want to modulate with the LFO. In most ready-made keyboards that you might buy, synths, analog synths of the past generation, there's knobs to use your LFO to affect either your oscillator, your filter, or your amplifier, depending on whether you want vibrato, tremolo, or wah-wah. So in the case of our modular, you're going to have to do that using cables. You'll have to first of all select the output waveform that you want from your LFO, and then you will have to route it to the respective inputs on your filter, amplifier, or oscillator. And most modular setups have sufficient inputs that you would not have a problem doing that. However, if you had a situation where you needed another extra input, you could simply use a multiple to break a cable and give you another way to plug into that particular input. Now, the rules as a rule are that one output can feed any amount of inputs, but you shouldn't mix outputs together. That's a basic rule in analog or digital electronics. You don't usually mix outputs together without a mixer. In other words, if you want to connect two outputs to the same place, they would go through a mixer. And that's a good rule to follow, although many of these modular synthesizers are designed in such a way that you can't damage anything no matter how you plug it up. It'll either work or it won't work, or it'll give you some kind of unexpected result, but you won't actually damage anything. I've chosen to just use another oscillator as my LFO and route the triangle wave that you see there into a multiple where I can send it to 4 different places. I send it to the linear frequency input of the oscillators, the 2 oscillators, and this knob here will regulate the amount by which I want to affect it. And then I send it here to the filter by this red cable here, and this knob here will affect the amount that the LFO affects the frequency, center frequency of the filter. And then finally I send it down here to the amplifier, and this knob here will adjust the amount that the LFO affects the amplitude. So in other words, to cause the tremolo, wah-wah, or vibrato to occur, I could have all of them at the same time by bringing up the knobs, or I could bring up one knob or the other, which is typical of the setup in the analog synthesizers, except that some of them have a switch, so it's not possible to send it to all the sources. You have to choose between one or other. I've set my analog here so that it goes to all sources, and to stop it from going to these sources, I simply turn the volume down on the level, or the level on the knob. So basically what I've wired here is a standard setup from which I can build numerous patches without even changing the wires, simply by turning knobs. Basically that's all I have to do now to build any of a multitude of sounds. But as I was indicating to you before, if we want to change the routing simply by pulling out cables or putting in additional cables, for example, if we want to sync the oscillators using the sync option, many of the synthesizers with 2 oscillators have a switch that you can sync one oscillator to the other. All we would do would be to plug the pulse output of one oscillator into the sync input there of the other one with a cable, and that would allow the sync. So we have to allow the latitude of plugging and removing cables in order to get all possible setups. But the setup as you see it here right now is good enough to make many different sounds. So in the third video we will actually show you how to create some basic sounds with this particular patch arrangement.